All right, guys, so we're going to start a new unit called Systems of Linear Equations. And if you can graph a line, you're in great shape, okay? So the first couple of things that we need to talk about is what exactly is a system of linear equations and what is a solution to a system of linear equations, okay? So the system of linear equations is just a set of two or more linear equations graphed at the same time. Okay, so I'm going to write that there too. Graphed at the same time on the same graph. Okay, so like this right here, that's a system. Okay, so imagine multiple lines being drawn on the same coordinate plane. All right, so multiple lines graphed all over the place. All right, sometimes they can make really cool shapes, other times they just like cross, sometimes you can't even tell if there's more than one. So there's a lot of stuff going on usually when it comes to systems. But one of the main questions that they will ask you on the EOC is, what is a solution to a system? Okay, now there are multiple ways to get a solution to a system. Okay, so a solution are points like x and y that both equations have in common. Okay, so specifically like a point on both lines, okay, or on both tables, okay, a point where the lines cross on a graph, so like where they intersect. So if two lines intersect, solution, done, woohoo, okay. An ordered pair that satisfies both equations when plugged in. And we'll talk a little bit more about that later, okay? So, as I'm looking for a specific marker, let's look at a couple examples of systems of linear equations. I know you're like, wait, that's it? And all examples? These are the kinds that, the more examples we do, the easier you're going to get it, okay? So, if you look here, what is the solution to the system graphed below? So, I already did the work for you. I already graphed it for you. So, let me grab my two highlighters. So this equation right here, y equals x minus 4. So if we plot the y-intercept and look at our slope, which is up 1 over 1, we see that this is that line, which means that this one, negative 2x plus 5, is this line. Okay. Now based off of what we know about solutions, in this case, it's going to be where they cross, okay? So, look where they cross. And no, the answer isn't, oh, hey, it's right there. Tell me what the point is. So, the numbers are a little bit off, so if I count 1, 2, 3, down 1, so it's at 3, negative 1. There we go. That's the solution. I know, right? I know. Pretty cool. Number 2, what is the solution to the system represented in the tables below? So, again, I've already done the work for you. In that, when I say that, I mean I've already plugged these into y equals, and I hit second table, second graph, and I looked at the points on the table, and I filled out the table for you. Okay, so I just kind of highlighted so you could see which equation goes to which table. So you can see, so if you have two tables like this, to find a solution, look for the point they have in common. Okay, so look for the same point. On both tables. Okay, so if I start here, nope. 0 is -5, -4. We have 1, -2, 2, 1, 2, 1. So, da 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 da. We have 2, 1 and 2, 1. So my solution is 2, 1. Stark, it can't be that easy. I promise. It is. Okay? For now. Okay? So looking at example 3 and example 4. I don't know if you're going to love me or hate me, but we're going to skip these. Okay? And the reason we're going to skip these for now is because we're going to learn and take a lot of time actually diving in to how to solve these types of equations and these types of systems. I know that actually quite a few of you could probably figure these out right now. I just want to make sure that we spend enough time on them at a later date to make sure that we truly understand what it is that we're doing with these. So we'll see these types of problems like next week. Okay? So let's go ahead, and you guys should have these, so flip them over. Okay? All systems have solutions. Okay? Every single type of system has a solution. So when it says what are the 3 types of answers, there are 3 different types of solutions. Okay? A system can have 1 solution. Okay? That's where they have 1 point in common. It's where they cross. Okay, so if we had 2 lines like this, and we saw this on the other side, or in a table where they have the same point where they cross, that's 1 solution. Okay? You could have no solution, okay, where there are no points in common. This means that those lines are parallel. Okay? So remember, and this might be from forever ago, but parallel lines have the same slope, but different y-intercepts. Okay, so those lines are going to look like that. Okay. Excuse me. Okay. So we have 1 solution, no solutions, or my personal favorite, infinitely many solutions. And the reason I like infinitely many solutions is because they have every single point in common, which means they're the exact same line. Okay, so what that might look like is we have this we graph this orange line and it's awesome. Okay, and then when we graph our second line, we notice, oh man, it's the same slope and it's the same y-intercept. It's the exact same line. Okay, that means infinitely many. Okay, so the easiest way, and I'm going to tell you this honestly, and I'm not saying this because I'm your teacher and I want you to practice, even though I do want you to do all of that. The easiest way to solve a system of equations is by graphing. Okay, so if you can get your equation into slope-intercept form, Yes, you can graph it by hand, or you can let the calculator do it for you. Okay? And then you're good to go. Okay? So solve each equation for y if you need to. Okay, remember, and I'll write it here too. Kick out your x. I was about to spell x like it was a person. So kick out x, divide up your stuff. Okay, plot your y-intercept. Use your slope to get more points on your line. Connect the dots. What do they have in common? Okay. So solve each system by graphing. Again, we can do this by hand. We can do this in the calculator. Okay, so let me just show you real quick because I'm not going to lie to you. You guys are going to do it anyways. If I do this in the calculator, okay, so here, look at this. So I'm going to go to y equals. I'm going to clear those out. Ooh, yeah. And I'm going to type in this first one. Alpha y equals enter. We have 2/3 x minus 2. I'm going to go to the table. Okay. I see a lot of fractions, and that's so much fun. So, so I'll do this one in pink. Okay, so at 0, we have -2. 1, 2. Oh, I see what happened now. Okay. Well, that's fun. My table was going up by tens. That's no fun. I want it to go up by ones. Okay. That's better. Sorry for that brain fart, y'all. At 3, 0. Now I'm going to connect the dots. Okay, so there's our first line. Second line, I'm going to go ahead and clear it. -x plus 3. Look at your table. 0, 3. 1, 2, 3. 1, 2. 2, 1. 3, 0. So if I connect these dots, we see exactly where my solution is. Okay, solution's right here at 3, 0. Okay, so pretty easy when you get the hang of it. Okay, now if you watched the first videos where I asked you to do the review, if you look at slope dude, it tells you exactly what to do with these lines. Okay, so y equals a number. This right here, I'm going to do this one in blue. This is a horizontal line. Okay, which means this one is a vertical line. Okay, so horizontal means it goes through the point -2. So if I find -2, boom. So I have to go through this line, horizontal, through that one. And vertical goes through the x value at 2, so 1, 2. So this one right here. So where's my, here we go. There's my solution. Is that, what is that, 2? -2. Okay. So let's go ahead. My first equation, -4x plus 1. We're going to go back to our calculator. negative 4x plus 1. And we're going to look at that table, go second graph. Negative 1 is positive 5. 0, 1, 1, negative 3. Okay. That's a really steep line there. Look at that. Holy Toledo. Holy Toledo, Batman. Alright, but you're going to notice this second equation, it's in standard form. So we have to turn it into slope-intercept form. So this is where we kick out our x, divide up our stuff. Okay, so we're going to move this 8x to the other side by subtraction. So they zero out, so we have a 2y equals negative 8x plus 6. So we kicked out our x, we divide up our stuff. Divide by 2. So y equals negative 4x plus 3. And I'm going to do this in blue. So the first thing that I notice about this equation and the first one is that they have the exact same slope. Okay, that right there automatically tells me, and it tells me this only because I'm the teacher, so it clicked really quickly. If they're parallel, they have the same slope, but different y-intercepts. So if I go back to our handy dandy calculator, right, and I plug in negative 4x plus, plus 3, and I look at the table, negative 1 is plus 7, 0 is at 3, 1 is at negative 1, 2 is at negative 5. So look at how closely these lines are. Look at how close these lines are. I can grammar, okay? But they're parallel, which means they never touch, which means there's no solution. Okay? Let's look at number 8. The line graphed on the grid is the first of two equations in a system. If the equation for the second line is x plus 2y equals negative 6, what is the solution to the system? I don't need to know what the solution is for that. Like, I don't need, or not solution, I'm sorry, equation. I don't need to know the equation of this first line. I just need to figure out the equation for the second line and see if they cross. Okay? So I'm going to go ahead and rewrite this down here. So x plus 2y equals negative 6. So we kick our x out, okay? So 2y equals negative x minus 6. And we divide up our stuff. So there's like an imaginary 1 here. Just remember there's that imaginary 1. So when I divide by 2, I get y equals negative 1/2 x minus 3. So y-intercept, negative 1, negative 2, negative 3. Slope down 1 over 2, down 1 over 2. Connect, I'm sorry guys, didn't realize the paper was moving on me. Connect the dots. Solution is at 2, negative 4. Okay. A line graphed on the grid is the first of two equations of the system. Do I need to know the equation of the line that's already there? Absolutely not. Not irrelevant. Who cares? Not me. If the graph of the second equation in the system passes through the points 4, -3, and 2, -3, or -4, 3, and 2, -3, what is the solution to the system? Okay, so whenever you see a problem like this, okay, and they've given these types of problems on the EOC before, okay, plot the points. And connect the dots. Okay, so if I plot these points, so -4, 3, -4, 1, 2, 3, -4, 3, and 2, 1, 2, -3, 1, 2, 3. Wherever they cross is my solution. So -2, 1. Okay, let me know if you have any questions.